Hello everyone. I want to share a method which I recently found, which is quite effective, I think, when a lot of people are involved in making a really big feature and works quite nicely. So we're going to try to find a technique which we can use, which simplifies this problem and the original authors of those commits are retained. So when there's only one person who is involved in development, the things are quite simple because you can simply check out a branch from where you want to start, and then you can make your changes and finally merge to develop. So this is not so simple when real projects are involved, because you can have a lot of people who might be trying to make their changes. And so let's say you have four people who are trying to contribute. So each this feature itself can be broken down in three sub features, and each sub feature can belong to a single team. It may so happen that there are some people who belong to the same team, but they have to make changes in the same file itself, adjacent lines of code. So this makes things really hard, how to actually synchronize all of this and ship the whole feature as a single thing. The first approach that a lot of people do is they have their own sub feature branches, one per person, and they would do their changes in each branch. And based on the design, the contract they have made, they would make the changes. And then when everything is done, they would merge this in develop. This has some problems because first of all, you have not really done some testing, because you haven't gone through this integration branch. There is no concept of integration branch. There are some other problems which may encounter that, let's say the feature, because the feature has not been tested as a single entity like integrate, so uh, a lot of bugs may appear after you merge to develop, right? And there might be conflicts as well. So these people who might be editing similar lines of code, they might encounter conflicts. So things are really hard. uh, so what people do is they introduce this concept of an integration branch, where they try to test their changes through these cherry pick mechanisms. So what they do is they do their development as usual. It's pretty much the same, except that there is a separate branch which is called the integration branch, where they cherry pick their changes, and then they do their testing on this branch to see if the thing works. If it doesn't work, they would sometimes make changes in this branch itself, and then they would cherry pick to their main branch. And this goes on forever until we have the feature working. And then once everything is done, these original branches will be merged to develop. But even this has a lot of problems that we will take a look at later. But the main problem with this approach is that if you are doing changes here, and let's say you miss an important commit, uh, cherry picking. So because it was working here, you probably don't really care about too much whether you have cherry picked it to here. Sometimes you can forget. So this can cause really big problems if you are trying to merge it later, because that important commit might be missed, and this might not be present when you actually merge it. And this still doesn't solve the problem of conflicts, because conflicts can still come when you are merging these branches independently. um, this is why I want to share this approach, where there is a single master feature branch which is the same as integration branch. um, and this kind of solves the problems that we're going to see here. So the main problems we would encounter with these approaches is that in the first approach, where we have no integration branch, then we don't really know if the feature really works when we actually put it together, until we actually merge and then we try to run and then we realize that it's not working. So that poses a huge problem. And we are also solving any bugs which we encounter post merge phase. And this relies on a perfect design phase, that you have the contract really set and you have actually implemented everything as it was discussed in the design. And of course there is this problem that the subsequent committers, the ones who are going to merge later on, they might encounter conflicts. So, which is probably not good. And the other approach, we said there are chances that we can miss certain important commits, and there is this thing that this integration branch, when people are actually placing their commits in this branch, this may not be kept sanitized. So some people who may be wanting to test their changes, they may not be able to do this because some other person might have uh, pushed a commit that might have broken the whole build probably. So in this method, we have the concept of a master feature branch, which is the same as the integration branch. And the trick here is that we are going to use this branch as the single branch where people will keep on merging their changes as they do their tasks. So each sub feature can be thought of as a lot of tasks, and so whenever someone wants to make something, they would first fork out a branch from this branch, the main branch, and then they would do their thing, and then they would merge it again with the feature branch. Once everything is done, in this sense, every contributor has uh, done their tasks, they have merged it, everything thoroughly, we can squash and then merge it with develop. This approach is pretty good because this solves a lot of problems that we faced before in the other approaches. Let's talk about the method where we have this master feature branch. So the very first thing you're going to do is that we branch out the main master feature branch from develop, and you can branch it out anytime you want. If you think develop might be unstable, you can always rebase later, and we'll talk about this more later. So the way you would branch out is like this, and then the next thing you do is push it to the remote so that others can access this branch. So now what happens is that each person who's going to contribute to this feature starts their development in parallel. They would first check out their branch for their task from this feature branch, like this. Each one of them checks out their branch and then they start making their changes. And then once, let's say, a person completes their task, they merge their changes immediately to the feature branch. So what this allows is that now, if when they merge, the other contributors who who are going to make their tasks, they can now access these tasks that this person has just pushed. So if you're using Git, you can do this using this. So first check out to the main feature branch, and then your subtask branch you can merge, yeah, like this, and then push it so that others can access. If you're using Arcanist, then you can raise a diff on the feature branch, and then you can land it on the feature branch. This Arcanist method also triggers a fabricator diff, which runs the CI pipeline so that you can know if you are breaking the build, so that you don't accidentally push something to the feature branch, so that this branch is kept sanitized. And this also raises a diff which can be reviewed before merging to the main feature branch. The same can be, however, done using Git, using a pull request mechanism. Now, people can access these changes that this person has just merged to the feature branch. They can make more subtask branches from the master feature branch, which already has those completed subtasks. So the first thing you would do is go to that master feature branch, pull the changes so that you can see those changes which others have done. Then you would create another subtask branch like this, and then you do the same thing again. You'll commit these changes and then merge to the feature branch. This way you will keep on doing those changes and keep merging to the main feature branch. Now it's possible that you can rebase these subtask branches with the feature branch. However, this requires that the master feature branch must not be rebased since the subtask branch was forked. If this is to avoid a problem which can happen, which because of which you can encounter a lot of conflicts. So I recommend, if this happens that someone has merged the main feature branch, then you can cherry pick those changes to a newly fork branch, which you can later merge. So let's say everything through this mechanism, you have completed all of your subtasks, and the feature can be called complete. Now it's possible to raise a review if required, if these reviews were not done during the subtask branch merges. This review can be raised using Arcanist like this. So you'd first go to the feature branch itself, and then you'll raise this review like this. So this through this mechanism, you can add reviewers, which will which might add more fixes in, and then once you commit those changes, you can raise the view again and then update the diff if required. This diff is only meant for review, and we are not going to merge this directly into develop using Arclan. This is because there will be a single author, which we don't really want. We want to retain the original authors in our approach. So let's say you have finished the review phase, and now we can say that the feature can be called complete. We can now rebase this feature branch with develop, and then we can solve any conflicts. Now it may so happen that there are a lot of commits, maybe 15 to 20, that are that some of them may be very short, which should not ideally appear on develop. So what we can do is squash those commits with some of those previous commits, so that we can have really a very less number of commits that actually get merged with develop. So um, what what we want to do here is that we want to run this get rebase I develop. This starts an interactive rebase process where you can squash some changes with another commit. So what will happen is that you'll replace pick with squash in front of those commits which you want to be squashed with the previous commit, and this way you can reduce this number of commits that that are going to end up in develop. So ideally we don't want that there should be more than 5 to 10 commits. Now is the time when squashing and everything is done. Now we can safely merge this feature branch to develop like this. First go to develop, and then go git merge the feature branch, and then finally push. This approach has a lot of advantages with the conventional approaches. So with constant inflow of freshly merged code from other contributors, the development and testing much faster, because you are able to test those changes really fast, and no cherry picks can be missed, because the integration branch itself is the feature branch. So there is no chance of anything missing, unlike the previous method. And through this mechanism, we can also squash commits, so that we can minimize the number of commits that are actually going to appear in develop. So when should you actually rebase the master branch with develop? So in order to avoid a problem which can happen where you are encountering a lot of conflicts, I recommend that we rebase the master feature branch with develop only if there are no sub feature branches present, in order for everything to work smoothly. If you have any suggestions, please do let me know down below in comments, and thanks for watching.